This video is going to talk through the Gaddis 9th edition. This is not the textbook that we have, but it's going to talk about exceptions. And so, first of all, exceptions are going to be used to indicate something unexpected has occurred. Usually this is during runtime, and it allows a program to deal with a problem in a controlled manner so it doesn't like crash. And you can also be as simple or complex as you would like, okay? So when we say exception, it's an object or a value that signals an error. When we throw an exception, that's sending a signal that an error has occurred. And when we catch or handle the exception, there's a process in place that is making sure that the exception is being taken care of or sends a message. So when we work with a throw statement is followed by an argument, and it's used to throw what's called an exception. The try is followed by a beginning and ending curly brace block, and it's used to invoke the code that throws an exception. The catch is followed by a block with curly braces, and it's used to detect and process exceptions that are thrown in the preceding try block. It takes a parameter that matches the thrown type, so you have to match up parameters. When a function throws an exception, it is within the try-catch block. If a function throws an exception, it terminates and the try block is immediately executed. A catch block to process that exception is looked for, and then the source code immediately follows. It's looked for immediately after the try block. If a catch block is found, then the exception is thrown, is executed. So using an example with functions, this one it's just error trapping for days of the week. And so if the days are valid, and we're going to do one similar to this, we're going to throw invalid number of days. So what we've done in the past is just see outed a message that says something like invalid data. Now we're going to use this try catch block, and we're going to throw an error. And if that error is not thrown, if this all works fine, then it's going to return the 7 times week plus days, whatever it was calculating out. A second example, this is the try catch block, and so this is the code that actually would be tried. And so if this code total days is called, if total days is called and works fine, then it's going to output the days. Otherwise, the exception will be thrown, and it will come back here, and a message will be printed. Now this is being this asterisk here is indicating that it's a pointer to a message, and that's just the way that it's being sent in, and it's going to output that message. And so whatever you have back on the previous right here, this invalid number of days is going to be thrown. That's the message that will be brought in here, and then it will be printed out. So again, this is kind of just echoing what happens. The try block is entered, total days is called. If the first parameter is between 0 and 7, then it works without a problem. If, however, we enter bad data and the exception is thrown, then the try block is immediately exited. The catch block scans for the first one that matches the data type thrown, and then it will execute that catch block. So you can have multiple catch statements. And if you have more than one catch statement, it looks to match up the data type. Like this one's a character string, and so it's looking for a string. If it doesn't find that character string or string of characters, then it might go to another catch block that has a different data type. This is another example of a try-catch block where everything is written all in main. And so if this try block does not work, an error is thrown, and it is caught here, and then the exception is printed out. And this one, I believe, would just print out whatever there's kind of like the system or C++ has some default errors. Notice these are programs from your text, from you have programs similar to this in your textbook, but they're not from section 16.1. I'll have to look up what section they are for you, okay? And so this is an example here. If the denominator is 0, the message is cannot divide by 0. And now this one then returns static cast double numerator divided by denominator. Now this static cast double has nothing to do with the error message here. This is just making sure that you don't do integer division, okay? The try-catch block here, or this division by 0, this actually isn't even a try-catch block. This is what you would probably do before the try-catch block. Oh, I'm wrong. It does throw an error, so I apologize. So what we had done before is if the denominator is 0, we would just see out. So instead of see outing, we are throwing an error. If this gets and so the code that we want to run follows immediately after this, and that's because if this error is thrown, the code quits executing, so we won't even get to this statement. If it passes denominator by 0, then it's going to go ahead and execute this. But this is good to point out because a lot of you have integer division errors, and so this static underscore cast double casts numerator as a double, so it makes sure that it does the correct division. Again, this is just another way of showing what happens with the try-catch block. So you try the code, and if the code throws an error, then you catch the exception here, and the message that is in the exception will be printed. If no exception is thrown, then it skips down to the rest of the program and executes the rest of the program as expected. Predefined functions such as new may throw exceptions. The value that is thrown back does not need to be used in a catch block. In this case, no name is needed in the catch, and a catch block parameter definition does not have to have the type of execution being caught. So this would be, I think, just like a generic catch block. If the exception is not caught, if it is thrown from outside a try block, there is no catch that matches the data type of the thrown exception. If an exception is not caught, the program will terminate, and it may terminate in an in a not nice manner, so to speak. Exceptions and objects. An exception class can be defined in a class and thrown as an exception by a member function. An exception class may have no members or members, either one, and a class can have more than one exception class. This is actually talking about an exception class that you might write for your whole entire program. And so as an example here, with their rectangle class, they have the specification file for a rectangle class, which is your .h file. And so they have a couple instance fields, and now they have written an exception class, and it's called negative size. So this is showing how to put exceptions into a class. It's just showing the rest of the .h file. And then within the rectangle, we looked at this once already on another screen, but you can then throw a negative size exception right here, and then it would run that code for the exception. So this is an example. If you need this code or want to see this code, I can get it to you. Here is the catch for the negative size, and it just outputs error, a negative value was entered. So it looks for this negative size, rectangle : negative size, and that's what the error is being thrown. And so when we throw that error, it's going to look for this negative size, and then it's going to print this error message. And that's what the output would look like. After the catch block, once an exception is thrown, the program cannot return to the throw point. The function executing the throw terminates. It does not return, and other functions in the try-catch block terminate. So it's called unwinding the stack. If objects were created in the try-catch block or the try block and the exception is thrown, then they are destroyed. That's when the deconstructor would be executed. You can have nested try blocks. And so you can Google more information on that if you want, because that's all that's going to be on this PowerPoint. Okay. So you can go back through this. It is attached on our resources on Blackboard if you would like to dig into this a little bit deeper.